guys, welcome back to my channel. I am Ranjitha.G, currently studying in Sri Venkateshwara College of Engineering from Department of Basic Science. I am from first semester in Computer Science and Engineering. The subject is Applied Physics. The topic is Physics of Animation and Statistical Physics for Computing. The contents which we are going to study today is Physics of Animation, Introduction to Animation, Principles of Animation, Statistical Physics for Computing, Poisson Distribution, Monte Carlo Method, Bell Curves. Physics of Animation. Introduction to animation. What is animation? A drawing that moves or bringing the drawing to the life, moving something which can't be moved itself. Animation is a powerful tool capable of communicating complex ideas, how the heart beats adds visual impact to the project. Principles of animation: overlap, squash and stretch, anticipation, arcs, slow in, slow out, appeal, timing, 3D effect, exaggeration, stagging, secondary action, follow through. Falling and speeding up, rising and speeding up, rising and slowing down, falling and slowing down. These are the major steps that are involved in the moving with the character in animation process. Taxonomy based on the animation. Since animation is an illusion of a movement in sequence, one need to consider the physics of motion. There are two categories in this. They are kinematics and dynamics and inverse. These are the major steps that are involved in the taxonomy in animation. Timing and spacing in animation. Timing refers to the number of frames or drawings between two key poses, which determines how fast or slow the action is. And spacing refers to the distance between each frame or a drawing, which determines how smooth or jerky the motion is. By adjusting the timing and spacing of your animation, you can recreate different effects such as anticipation, exaggeration, squash or stretch, ease in and ease out, and overlapping action. Walk style in animation. Another fundamental skill for animators is the walk cycle, which is a loop of frames that shows a character walking in a place. A good example of walk cycle animation, this one by Preston Blair, a re-owned animator who worked for Disney and MGM. Notice how he uses timings and spacing to create a natural and expressive walk for the creator. Using the principles of squash, a stretch, ease in and ease out, and overlapping actions, he also uses a different timing and spacing to show the personality and mood of his characters such as happy, sad, angry or sneak. Walking cycle plays an important role in the animation process. Lip sync in animation. A more advanced skill for animators is the lip sync, which is the synchronization of the mouth movements and expressions of a character with a dialogue or a sound. A good example of a lip sync animation is the one by Aaron Blaise, a former Disney animator and director. Notice how he uses timing and spacing to match the mouth shapes and emotions of his character with the words and intonation of the voice actor. Lip sync in animation plays as this important role in the animation. Landing in animation. As he lands, have him go down as you would squash the bouncing ball. Really compress his body to take the impact or push the spine into a strong C shape to once more contract with the previous stretched pose and its straight spine. Going from this big to small shapes and back again will also really add to the appeal of the animation. Really push these early poses, making sure they are as clear as can be. Spend time here to make your poses readable, and if needed, create a play blast or draw over it in neat notes as you are not restricted by a rig. Landing safely. This is the image of landing in animation, which is the important role in animation. Now, statistical physics for computing. Descriptive statistics. In short, help describe and understand the features of specific data set by giving short summaries about the sample and measures of the data. The most recognized types of descriptive statistics are measures of center, the mean, the median, the modes, which are used at almost all levels of a statistics. The mean or average calculated by adding all the figures to the data set and then dividing by the number of figures within the set. This is the descriptive statistics. Next, the inferential statistics. Inferential statistics is the study of sample of the same data, for example, grade and percentile. Inferential statistics is a branch of statistics that makes the use of various analytical tools to draw inferences about the population data from the sample data. Apart from inferential statistics, descriptive statistics forms another branch of statistics. Inferential statistics help to draw conclusion about the population, while descriptive statistics summarizes the features of the data set. Poisson distribution. A Poisson distribution is a discrete probability distribution. It gives the probability of an event happening a certain number of times k with a given interval of time or a space. Poisson distribution is a discrete probability distribution. We can see the image here. It can happening a certain number of times with it can given in an interval time or a space. The Poisson distribution has one and only parameter, that is lambda, which is explain the number of events. The graph below are the example of Poisson distribution for the different values of the lambda. Monte Carlo method. This is the image of the Monte Carlo method that is estimated for the pi. Monte Carlo simulations have a vast array of applications in fields that are plagued by random variables, notably business and investing. They are used to estimate the probability of cost overruns in large projects and the likelihood that an asset price will move in a certain way. Telecoms use them to assess network performance in various scenarios, which helps them to optimize their network. Financial analysts use them to assess the risk that an entity will default and to analyze derivatives such as options, insurers, and oil well drillers also use them to measure the risk. This is the Monte Carlo method definition. Bell curves. This is the image of the bell curve. It involves unacceptable room for improvement. Metals expectations exceeds expectations. Outstanding. The term bell curve is used to describe a graphical depiction of a normal probability distribution whose underlying standard deviation from the mean create the curved bell shape. A standard deviation is a measurement used to quantify the variability of data dispersion in a set of given values around the mean. The MEL in turn refers to the average of all the dispute points in the data set or sequence and be found at the highest point on the bell curve. Bell curves are described as graphical depiction of a normal probability distribution, as we can see in this image, whose underlying standard deviation from the mean to create the curve bell shape. A standard deviation is also the measurement to use to the quantify the variability of data dispersion and etc. and the values given around the mean. Thank you for watching my video.